Keep in mind that the approximate meaning of standard deviation is the average distance between the mean and a score in the dataset. Using the 5 quiz scores from an earlier video in which the mean score was 17.2 out of 20 possible points, we can find the deviations of the 5 actual scores. A deviation is x minus x bar. X is each score one at a time. X bar is the mean average of the scores. So x minus x bar is the difference of each score and the mean. We end up with these 5 deviations. The negative 3.2 associated with the score of 14 implies that 14 is located 3.2 points below the mean average of 17.2. The deviation at 2.8 is associated with the score of 20, since 20 is 2.8 points above the mean quiz score. If we added up all of the deviations and divided by 5, we would get a mean deviation of 0. Well, this makes sense actually. The mean is the average score, balancing the scores above it with the scores below it. Thus, the average deviation is 0. The sum of deviations is 0. But we need to use deviations to help us convey how spread out the data is. So we could calculate the mean of the distances of scores from the mean. Distance is absolute value of the deviations. The formula would be this. N is the sample size, and the Greek capital letter sigma tells us to add up all the absolute values of the deviations. The result is called the mean deviation. But this statistic is not as powerful as the actual standard deviation. Standard deviation is hugely important, so pay attention. Instead of using absolute value to get rid of negatives, we will square all of the deviations, add them up, and divide by n minus 1. n minus 1 is 1 less than the size of the sample. In later videos, I'll address why n minus 1 is used, but for now, just follow the formula and keep in mind that standard deviation is reasonably close to the mean distance of a score from the mean. Here's the formula for standard deviation being represented by lowercase s. First, you square all the deviations, each x minus x bar. Then add them up, take the summation. And then divide that sum by n minus 1. Finally, take the square root and, by golly, the standard deviation. Variance is another important statistic. It is the square of the standard deviation. Our standard deviation was 2.39. Squaring this yields a variance of 5.7. If we're given variance, we can take the square root to find standard deviation. In fact, during the use of the standard deviation formula, before we took the square root, we actually had the variance. The formula for variance, then, is this. For more clarity and reinforcement, watch the video on more of standard deviation and variance, and to see how to use the graphing calculator to get the standard deviation and other statistics, watch the video Statistics on the calculator.